Final topic we're going to address is carbon capture, utilization, and storage. And so this is the either you can view it in either of these two ways. One, this is how we pull the carbon that's already in the atmosphere out of the atmosphere. Or B, if we are not going to be very successful at totally decarbonizing the economy, so to speak, this is how we might limit the amount of carbon that we continue to put into the atmosphere as we decarbonize, so to speak, certain processes, even if we're continuing to use fossil fuels. Again, I have a great video from CNBC that explains what this is all about, but let me just give you the overview of what it takes to make this viable. First of all, you need an inexpensive capture. Now, there's two ways to do that. You can capture it at creation, which, for example, for an automobile probably isn't very realistic, but for some major industrial processes is more realistic. Or you can pull it out of the air, which you're going to view more about in the video, and we're going to talk about more in class. None of this is easy or inexpensive. It's technologically proven, so it's not a science project, but it's just expensive. So first of all, making the capture as inexpensive as possible is helpful. The second is to have a secondary use for the CO2. For example, I'll announce a project, or I'll tell you about a project here in a couple of slides. They've got a real natural use for their CO2. They're going to use it in their enhanced oil recovery operations. In other words, they're going to be injecting it into wells to increase the oil flow from those wells. And if you don't have a secondary use for it, then you're looking for inexpensive storage near the capture location. So those three elements, and really I should put on there a fourth element, which is government subsidies, and we'll talk about that today too. There are a lot of things happening in the CCUS world. Occidental Petroleum, or Oxy, is partnering with Carbon Engineering, and they've actually, I think, broken ground this fall on a direct, and I should say the fall of 2022, on a direct air capture facility plant in the Permian Basin that's going to capture, they say, have a capacity of 500,000 metric tons per year, which again, obviously they have the use of being able to put it right back into their wells in terms of enhanced oil recovery. ExxonMobil is planning, and the key word there is planning. They've not decided to do it yet. They've not broken any ground, but they're planning a CCUS storage facility near Houston. Houston is being discussed as a hub of the hydrogen economy in the United States for a couple of reasons. First of all, it has a lot of good formations, both offshore and on land in Texas and in Louisiana, where they think it would be good places to store the carbon. Also, you have a lot of facilities that generate a lot of carbon in industrial facilities, specifically some of the chemical plants and the refineries, where these might be good places to capture the capture the carbon dioxide at its creation source. So Houston is talking about becoming the hydrogen capital of the United States, much as Houston is considered the fossil fuel capital, or at least the oil and gas capital of the United States. And there are provisions in the Inflation Reduction Act regarding CCUS. Previously, there was a credit of $50 per ton, or a maximum credit of $50 per ton. Under certain circumstances, it was less than that. And under the Inflation Reduction Act, the incentives have been raised to as little as $60 per ton and as much as $180 per ton. And how much that incentive is depend on the nature of the capture and where it's stored. That $180 per ton incentive is based on direct air capture being stored in saline formations. So you're going to see in some of the video, or in the video, that they think about $100 per ton is where CCUS becomes economic. So you can see these subsidies could stimulate quite a bit of activity in the CCUS market. So as we wrap this up and we think about the future, I want you to see that there are certain common denominators to all of this future of energy discussion. The first is that cost is always an issue. fossil fuels are relatively inexpensive with a lot of energy punch. And so finding a replacement without dramatically increasing the amount that people have to pay for that energy is always going to be a challenge. Often when you hear things, you need to have the discernment to separate out whether it's a science project or whether it has progressed to the point where it's a real innovation. So when you heard that talk a lot of the batteries, what you saw was a lot of laboratory work, and that's important and it's essential, and it is the first step. But the problem is you don't know what's actually going to make it out of the laboratory, make it into the field, scale at a cost that is economically viable. So as you read about these things, always be evaluating those sorts of things. How far along is it? Will it scale? How much will it cost? And that issue of will it scale is far more important than a lot of people think it is. And so I'll just close with saying, which of these do you think are the most likely? And trust me, there's opinions all over the map on that. And I hope now that you're motivated to pay attention to the news about the various, to the progress that's being made on these various types of future of energy projects. I think I'm making this in the fall of 2022, and we have a great guest speaker lined up to talk about carbon capture. And I look forward to that discussion.